Okay, this is the continuation from the second lecture. We have covered the motion of a rigid body which is undergoing a rotation and angular acceleration, and this is done in a free space. And after that, we know the position vector, and we will try to, and we represented the vector for the angular acceleration and also the angular velocity, and we know the relative position of B relative to A, and then we find the velocity of B relative to A and the acceleration of B relative to A, and we can do the calculations related to the velocity. Now we continue with example 3. We shall now continue with example 3, where we will combine this motion. And this is perhaps the beginning of our understanding of, or the true application of the kinetics of rigid body. And let's say we have a link. Yeah, and the first link is, let's call this link as, is pivoted at O, and there is another joint here, a pin joint at A. Yeah, and let's say at the same time we have another link here, and this is point B. Okay, and O is rigid, and at the time shown, this link is making an angle of 30 degrees. Okay, or rather, to make it easier for us, we'll just say that this link is 5 meters. That's not 30 degrees. Let's take this 30 degrees, and it is a 3, 4, 5 kind of gradient. So 3, 4, 5 is a well-known Pythagoras. And let's say the distance between B and A is 4 meters. Yeah. So you got this condition of OA and AB. AB is purely horizontal, and OA is given as in the position of triangle, at right angle triangle at 3, 4, 5. Yeah, and let's say that in this case, OA is moving, has an angular velocity of, let's say, 2 radian per second. Okay, and at the same time, it also have angular acceleration alpha. It has an alpha of let's say 8 radian per second square. Yeah, and AB also has a omega AB, which is clockwise, and let's say omega AB is 10 radian per second. And just so that, and there's no alpha AB. Let's assume that alpha AB is 0. Okay. And what is the question here? The question here is determine the velocity of B and the acceleration of B. Okay, and also the velocity of A and the acceleration of A. Okay, so that would be the question for this example. This is a case where we combine the previously rotation about a fixed axis. OA is a rotation about fixed axis. BA, it is not a fixed axis because point A is moving because it's on the link OA, so point A is moving, so it can be a general motion. So in order for us to solve this, we need to go one step backwards, which is we need to find the position vector of the system. So this will take a bit of explanation. Yeah. So from this setup, you can easily draw the position vector. Yeah. So this is the position vector. This is the position vector B relative to O. So this one is position vector B relative to O. And you can now also easily show that this is position vector A relative to O. And of course, this is the position vector B relative to A. If you remember from the first or the lecture related to the particles, kinematics of particles, we can now write the position vector as position vector B relative to O. And remember, because O is not moving, so it's fixed, we can put it as absolute. So position vector B is equivalent to position vector B relative to A plus position vector A relative to O. And O is fixed, so I will not write A slash O, but I will. And from there you can find you can write the velocity equation. So VB equals to velocity B relative to A plus velocity A. And then we can write the acceleration equation, acceleration B equals to acceleration B relative to A plus acceleration A. Now, until that point, it would be, seems to be quite straightforward. Yeah. Perhaps what we can now do is find the individual components of the equation. So let's start with the velocity first, if we can. So what do we know? We know that velocity A, because OA is moving, OA is moving about a fixed axis O. OA is moving about a fixed axis O. This is fixed axis O. This is the axis, fixed point. So it can be treated as a rigid body of a rotation about a fixed axis. So the velocity can be taken as omega OA cross position vector A. We know that from our observation, OA is 2 radian per second counterclockwise. So in this XY, so we have not labeled our XY, so let's say this is our XY. So from our XY, we know that omega OA is counterclockwise, so it will be 2k radian per second. Okay, because of space, I don't write the units there. And then we know that position vector A is 3 units to the right and 4 units to the top. So 3i plus 4j. I'm using the 3, 4, 5 here. So it's 3i plus 4j. Yeah. So that you can now write the position vector as 2k cross 3i plus 4j. K cross I is j, so we got 6j plus k cross j is minus I, so minus 8i. So your answer is 6j minus 8i meter per second. Yeah, so that is our velocity of A. And then we can find the velocity of, we need to find, because we got this equation, yeah, we know what VA is. We need to find VB relative to A. So what is VB relative to A? We can see that VB relative to A, VB relative to A, because it is rotating about A, so we can say this is omega AB cross position vector B relative to A. Yeah, so B rotate about A. So B rotate about A. Yeah. So, and omega AB, what is omega AB? Omega AB in this case is 10 radian per second, 10 radian per second, clockwise, so it's minus 10k. Okay, and then what is position vector B relative to A? It is 4 meter to the right, so it's 4i, so that we can find the velocity of B relative to A equals to minus 10k cross 4i. K cross I is minus j, so 10 minus 40 minus j, so we have 40j meter per second. So that's your this is, so VB relative to A equals to omega cross R. So omega is minus 10k, position vector B relative to A is 4i, k cross I is minus j, so minus 40 is 40j. So it is going downwards, say k cross I is j, sorry, this is positive j. Yeah, so this is minus 40j. So this is going downwards. Yeah, so we have a case. So we know that VB relative to A is minus 40j meter per second. So we now look back at the equation of velocity VB equals to VB velocity B relative to A plus VA. So we can now write the velocity B. So VB is VB relative to A plus VA, and that is minus 40j. Yeah, this is minus 40j, and VA is given as 6j minus 8i. So the answer would be minus 40 plus 6, so it's minus 34j minus 8i. So that is, and the unit is meter per second. That is the, I hope I don't make any mistakes in the calculation. If I made some mistakes, please let me know, yeah? So that's the velocity of B, and as we know the components, we can find, next we will do the acceleration of B.